All right. Hi, everyone. My name's Leon. I work for Fastly, where we make the web faster. It's in the name. But today I'm going to talk about a tool that we use called WebPageTest. I'm very happy to be here at London Perl Workshop because I've been at all the Perl workshops, having helped out with many of them. So we're going to talk about what is web performance. We're going to introduce WebPageTest, the tool itself, and see how we can use it and run a report. And then we're going to get a big, scary report. So we'll dig through the report and all the small parts, all the parts of it, and then we'll have some conclusions. And in between this, I'm going to have some Leon top tips for web performance, not just general top tips. So web performance is when you're going to a presentation and you want to see the whole slide at one time, right? But the slide goes so slowly that you really can't see any of the content. It's like when I go to a website, I'm trying to achieve a task. I don't want to wait for the image to load or for the fonts to load. I want everything to come in as quickly as possible because I am very, what's the word, impatient? And so are your customers, so are your users. You should try and make your experience for your users to be as best as possible. And if you do that, they might come back, they might stay more often, they might even buy more of whatever you're selling. And you know, websites are pretty big these days, maybe a little bit too big. Websites need to go on a diet, right? Doom, which came out a little while ago, was 2 megabytes of data. And that included levels, sprites, music, like AI for the characters, and like a plot and chainsaws. But the average web page is also 2 megabytes, right? And do you get the same amount of enjoyment from loading one web page than you might out of hours of playing a computer game? I was like, I don't think so. So this is the same for mobile and for desktop browsers, and they involve around 70-ish requests, 80-ish requests as well. Generally, you're only trying to get one piece of information out of a website, so this makes me sad. What can we do? Why have we come to this? Maybe we could try and figure out what is going on so that we can improve the situation. So here's my first top tip. If we don't measure it, we don't know what it is. So we should all start measuring web performance. How are we going to do that? There is a tool called WebPageTest. It's an open source tool. It's supported by volunteers and sponsors. So if you want to help or contribute, that's very appreciated too. It allows you to test a website from many places around the world at different connection speeds from different devices or from virtual browsers such as Chrome, Firefox, and IE. And it instruments the browser and gives you an idea of what the browser is doing when it is loading the page. And it gives you some top tips of how you might improve the situation, of how you might load the page faster. So all these sponsors help sponsor the site and keep all these agents running around the world. It's at webpagetest.org, and it looks a little bit like this. So you type in the name of the website that you want to analyze. In this case, I'm going to analyze the website that you have all seen is London Perl Workshop website. So I'm going to type in HTTP YAPC Europe/LPW 2018. And I'm also going to do a few things. I'm going to pick a real device because I like to see this on real devices rather than virtual devices. So I'm going to pick an iPhone 8 device, which happens to be in Washington. And I'm going to pretend it has a cable connection, although it's Wi-Fi, but we'll go with a cable connection to the Wi-Fi. Make 3 requests, so we can have like a mean, of not the fastest, not the slowest, but like the one in the middle. Make a repeat view, so view the page once and then view it again. And capture video, because that makes pretty pictures. And when you start the test, what it does is it talks to the iPhone, it asks it to load the page, it instruments all the data that's coming through the browser for the iPhone, in this case it's Safari, and it takes a few seconds. It might be that lots of other people are testing with the iPhone, but you have an idea of the length of the queue. So it might take tens of minutes, it might take 30 seconds. And once you the test is finished, you get a long report. And the report is quite tricky. There's a header at the top. There are some grades. There are some links to more pages. There's for the 3 runs, and for the first and repeat view, and then some more stuff as well. We'll go through it. So here's the header. So it tells you what the test was and the parameters of the test, and gives you some grades. We'll go through the grades in a minute. There's the links to various different parts. So here's the summary view. You can even download the data to do more analysis on your site if you want to. And then the performance review tells you some top tips is for every resource that the page has loaded, does it follow the best practices for that resource? And we'll go through these as well. And then there's content breakdown. So for all the assets on the page, what type are they? So in the case, most of the requests were for images, and how much of the bytes in total that is needed to download the whole page do they take up? So most of the assets is images, and then JavaScript, and then fonts, and then CSS, and then HTML, which contains the content that you actually want to see, is only 8K in this case. So then we get a scary-looking waterfall chart. I'll cover this later. And then a domain breakdown, so you can see where all the assets have loaded from. So in this case, most of the assets have loaded from the ACT website. Makes sense. And then the rest of them are from Google domains. That's because there's a Google map at the bottom of the page. And similarly, you can do that by bytes. So most of the assets are loaded from the ACT website. That was the images. And then the rest of JavaScript is all from Google Maps and things like that. So here you can see if assets are coming disproportionately from somewhere else. And then there's a screenshot, so you can see what the browser source, in this case Safari, the iPhone 8, took the screenshot here, and it's good. It's got the header, it's got the pretty image, and just got the date, but not the location on the just above the fold. So I guess you could use this to say maybe we need a little bit less space under the screenshot, so we could have the location on the page without anyone having to scroll. And then it also picks some heroes. A hero is the most important thing on the page. So in this case, it picks the heading, fair enough, which is only visible 4 seconds in, or almost 4 seconds in. That's not great. And then the most important image, which is the background image, which is also only visible 4 seconds in. That doesn't sound great. We'll see why that is. And then of the 3 runs that it took, it picks the median run, so the not the fastest, not the slowest, but one in between. And there are all sorts of interesting metrics. So the one I particularly like is the speed index, which is a measure of how quickly the page is loading in like visual progress. So how much of the final page is loading over time early on. And also, two important ones are the document complete, which is when JavaScript has decided all the assets loaded and JavaScript can start running. And fully loaded is when all the assets of the page have completely loaded. But you know, there's like a $ on the right here, because you have to worry about cost, right? How much money does your website cost to the person looking at the page? So this was about 1 megabyte for the home page. So that would cost me, on my 3 pay-as-you-go, about 1 pence to load the page. Is this page worth 1 pence to me? Yes, because I need to know where the venue is and how to get here and the schedule. But maybe all your pages might not be worth that much money, right? If you're on pay-as-you-go, you could be paying up to like 10p per megabyte in the UK. And if you're in other countries, so Canada, very rich country, but has very expensive mobile, and poorer countries, you may be paying a significant amount of your paycheck in mobile data as well. So you have to worry. It's loading a web page is not free and costs your users money. So to be happier to our users, we should reduce the total number of requests. So that should reduce the amount of content going through to the users, make it cheaper, and also load it faster. And we should also compress responses. I'll go through how we can do that for the different types of responses. The first big red box is a first byte time. So in this case, the first request to the ACT website to get a response back took took over 1 second. So admittedly, this test is with an iPhone in Washington, but still 1 second seems like quite a long time. Maybe there's some way we could speed up the server hosting the ACT website. That would help every response coming out of it. Using keep alive connections used to be more of a problem in the past. Basically, all servers do it now, so we don't need to worry about that. We compress the transfer of the HTML, and there's JavaScript, and there's CSS. These are all text formats, and these compress really well with gzip compression. And we should definitely all be compressing those. So always compress responses, especially these text formats. They compress to tiny. It's an easy win. But you should also compress images. The skyline, the London skyline image at the top was huge. But WebPageTest noticed that if you could even take this JPEG and compress it without losing any information, so losslessly, and save 20 kilobytes. Right? So even without making the image look worse, completely losslessly, you could have saved 20 kilobytes. So very worth compressing images. And in fact, my favorite tool for this is ImageOptim. It uses all sorts of best practice compression to compress losslessly, but also can compress lossy to make it look visually slightly worse, but you probably won't notice. And compress it to much smaller so everything loads faster. We've got a big red F for caching static content. The way that we cache, that you indicate how an object should be cached on the web is with a cache control header. You can say cache this for 30 seconds, cache this for a year, or don't cache this at all. And all these assets on the ACT website don't have a cache control header at all. So the browsers use a heuristic. And as we know, a heuristic is a fancy name of saying that it guesses, and it probably guesses wrongly. So we should always have cache control headers to explicitly tell browsers and any intermediary caches how long to cache the resources for. Content Delivery Network, the CDN, is a way of distributing content across the world. So if you have users around the world, a CDN is a great way to speed up the loading of websites. However, I might be biased because I do work for one. So I would generally recommend using CDN. Right, so onto the Filmstrip view. So this gives an idea of how the page is loading over time. So from seconds, so time goes to the right. And we're 2 seconds in, and we still have a blank page. So that's not great. And then like 2.5 seconds, we start getting a bit of content, but not the name of the conference, because it's white upon a now white background. And then eventually we load the background image, and now we know the name of the conference. So when you tested this on your $2,000 MacBook Pro on your gigabit connection, you may not have noticed this, right? You may have thought, it's like, it's great, we'll have a wonderful skyline image, it'll be high res, beautiful, but you didn't realize that you won't see the name of the conference on Wi-Fi perhaps, or 3G for a few seconds, and that's not great. So this is a good way of testing something on a slow connection and seeing what real users might do. Right, so onto the waterfall. Who here has seen a waterfall chart before? Okay, good. So much like the similar one, much like previous one, time goes to the right. So this is on the left is when the browser makes the first request to the page. The different colors are different types of resources. So purple is images, and fonts are like orangey. For every asset that is loaded by the page, you get a different lines. The first asset, number 1, is the HTML page, and afterwards we get some CSS, some JavaScript, some images, and all the way down. The yellow bar means it was a redirect, so it wasn't a final image. That was a Google thing. Nothing we can do about that. For the bar which is loaded, the colored bar is, the left is when the browser first made the request to the server, and the end is when it got the response, the final byte of the response from the server. You can see inside the bars it's slightly darker. That's when data is actually traveling to the browser. So the top one is we're making a TCP/IP connection. That's a narrow bar. And then we make a request around just after 0.2 seconds for the HTML. Then the browser waits. And only after, just before 1.2 seconds, is when the HTML comes back. And then the browser parses the HTML, starts issuing requests for CSS and JavaScript. And you can see here that this big red bar in the middle, that's waiting for the font. And the page is only rendered once the font is being displayed. So my takeaway here is like, take the font away, make the website 2 seconds faster. Same thing for connection views, and repeat views is actually doing quite well. The browser guesses correctly that it shouldn't reload all these assets. It just reads the HTML and then renders a page. And similarly for connections and repeat views. So my top tip is you shouldn't test with latest technology. You should try and pick like the median device and the median connection type that all your users have, or possibly even lower down, like a really low, really old Android phone, or like the cheapest Android phone you can buy, something like that. And then you'll get a good idea of how the page responds, how your website responds for some users. Now, I didn't use HTTPS before. I should use HTTPS. Let's make another test, because we want to secure all the things. And I was like, it's slower. So HTTP on the top, HTTPS is below. Why is HTTPS slower? I thought HTTPS wasn't slow anymore. It's like, because this is going across the Atlantic to make just a few round trips to get that TCP connection and upgrade to a TLS connection. So everything is shifted about 0.3 seconds to the right. It's like, okay, that's bad. So if we had a CDN, or if we were using HTTP2, that wouldn't look so terrible. So I made a few pull requests to the London Workshop GitHub repository. I compressed the images. I massively reduced the quality of the skyline image. And I made a few other changes. And I added a background color to where the skyline image would be. And then I made a new test. And my new test on bottom and the previous website is on the top. So you can see that with my background image, you can read the name of the conference. That's a good idea. But it doesn't actually look much faster other than that. And that's because since I did the first tests, lots of high resolution t-shirts and hoodie images were added to the website. And they offset all the optimizations that I had previously added. So you should bear in mind that web performance, maybe you should have a budget for web performance. And if you do add a feature or new images, you should take something away. You should never add forever until eventually your users go away and complain. And because I work for a content delivery network, I added content delivery network for testing in front, and you can see that not having to go across the Atlantic all the time, in this case, is very useful. It loads about twice as fast. WebPageTest has many different features. The most important feature is that it's open to everyone, and everyone can test, and you can share the link with everyone, and everyone can see the entire report and all the details. It can do so many different things. You could even run your own web page test instances in your office if you want to do thousands of requests. You can even hook it up to your continuous integration environment so that whenever you make a change, you see whether it has made your website significantly slower. You can even script it to say log into here and then go to this page and then do something else. You can capture network packets. So if you think something's going on the TCP/IP level, you can have a look at the packets and download the TCP dump. And there's a forum where you can ask questions, and people often ask questions like, what's up with this page, or why is this request so slow? But this is a synthetic test in a data center or in someone's basement. It does not necessarily represent your users. So London Poet Workshop users come from around many different places, around the UK, around Europe, who knows? So in that case, it's not really a silver bullet. If you really want to ask your users, you should ask your users. You should not ask a tool and pretend it represents your users. But on the other hand, it is pretty useful. So you should measure web performance. Do we agree? No one agrees. We should try not to have too many requests. So in this case, not adding all those high-res images without taking anything away. You should try and compress responses. Definitely HTML, CSS, JavaScript as gzip, and images in modern image formats, and compress losslessly. Try not to use latest technology when you're testing, or maybe do demos develop on very fancy computers which make you happy, but present demos on old or representative devices. Try and cache as much as possible, and possibly use a CDN if your users are around the world. Thank you. I will be around here for the next 10 minutes if you like any questions. Yeah?
I guess the first thing that happens when you go in and you go to site these days is that a little message comes up saying you agree to have this GDPR compliant thing. Mm-hmm. How does your web page test handle that block to your workflow, block to your data?
So the question was about pop-ups for GDPR compliance, things like that. And it's possible to script web page tests. So you can say, click on this like cross icon, I guess, or accept cookies, or you can ban certain JavaScript files. So if that happens to be a JavaScript file, that pop-up is a JavaScript file which you can ban by URL, then it cannot load that JavaScript file and thus load the page entirely. So you did a test on the WebPageTest?
No, against the BBC.
On what BBC website? Oh, that's interesting. I wonder why. So some locations have a big queue of people building it up, and as I mentioned, it's really run by the community, much like many Perl things are. So it could be that this particular instance is stuck and someone hasn't fixed it yet. I'd recommend running it again. It shouldn't take more than 30 seconds. Any other questions? So the question is about minifying JavaScript, and I'd probably compressing minified JavaScript, yeah, and I'd probably minify JavaScript anyway, and then compress it on top of that to try and get as much compression as possible, because then you can use more advanced compression methods such as Brotli, which is a different compression method which Chrome-based browsers support, for example. So you can try different techniques to make it as small as possible. Okay, excellent. Thank you.